we'll go through 35 and 36 like you guys asked. And hopefully kind of hearing my explanation here with this, hopefully it makes a little bit more sense. But also with these, sometimes just going back through the proofs and trying them on your own is a good idea. Even the same proof that you've already done, you know, together with me, like that maybe, you know, Sunday night when you're finishing up homework, go through one or two of the proofs and just practice that. It's going to be helpful to you guys just to get used to that format. So we will have a few more proofs in our homework tonight just to practice some more. Let's start with 35. All right, so in 35, we have our statements and then our reasons. So we start with our given statement, which is PQ bisects SPT, and then SP equals TP. So whatever the given is, I'm going to mark that. So SP equals TP is easy. This one is this and this. PQ bisects SPT. That means it cuts those into two equal pieces. Since it does that, I have to write that in the proof. So I'm going to write now that these two are equal because they got bisected. So SPQ equals TPQ. So those angles are congruent. So I just mentioned these angles being equal. And again, it's because we bisected the angle. So angle bisector. Now that I have that, I want to figure out what else we know. So hopefully you guys see that there's something pretty glaringly obvious that we know about this shape, is that we have that side that's shared. So that shared side, I do have to mention that though. So I'm going to mention the fact that this side is shared with itself. So PQ equals PQ. And that we call reflexive. So PQ equals PQ. And hopefully now you can see that based off of what we know about triangles, we have side, angle, side. So these two triangles are now congruent by side, angle, side. Now, if I go back in the proof, I can see that I showed two sides and an angle. Here's a side, and here's an angle. So I'm kind of just double checking that I included that in the proof, and so everything is kind of accounted for. 36 was a really short proof, but if you didn't realize the step that I wanted you to see in that one. It made it really, really tough because it's only 3 steps, and so if you miss the second step, you're missing, kind of the key to this problem. So totally understandable if this one did not go well. I actually think I used to have this on the test as a proof, and it was always a tough one. So I'm going to just put the given statements in the proof, just to save myself some space. This is V, X, Y, W, and Z. So I'm going to start with what I know. So this is all given to me. This is all given, so I'm going to mark that up. So they tell me that Vx equals xy. Vx equals xy. Then they tell me xw equals yz. That's that one. But then they also tell us those are parallel. Yeah. So all that is given to us. So we already have 2 sides, and we also have parallel lines. So yesterday, before you guys left, I think I quickly mentioned, and actually it's still up here on the board, is to watch out for corresponding angles when you have parallel lines. So hopefully you think this kind of looks like that. What this is talking about is like angles 1 and 2 be corresponding, so they should be equal. So in this case, we have these corresponding angles. It's kind of similar to the alternate interior angles. So like 3 and 4 would also be equal. But corresponding angles are here. And so if you miss that, it's totally understandable because it's just easy to miss and not see that happen. So the angle we have are these 2 angles because they would be corresponding. So our corresponding angles. And then finally, now we have side angle side again. So the triangles are equal. Obviously, I'm just being lazy there. So it'd be side angle side. We want to actually write out what the triangles are. Okay. So we will do a little bit more proof today. The proofs we do today are just going to build on one more step onto this. But at the same time, hopefully, there'll be a good review with that. We'll practice self-folding yesterday. It'd be like when we were leaving and saw you guys like walking out there. I was like, oh my gosh, whole new circle. Like, whole frame. Okay. Okay. Yeah. Yeah, and you'll be like in your room? Yeah. Okay. Well, thank you. All right. So the warm-up question today is kind of trying to go through some of the things we know about triangles and ways what things we can use in a proof. All right, so it is the 23rd. And again, I'm not sure completely on what I'm going to do about testing here. Like I said, it might just be a quiz, or we might just take an extra day to review and then just have some of this on our exam for this class. I believe we have our exams. Is it 1 and 3 are on Thursday, and then 2 and 4 are Fridays? That's right. For exams? I think so. So I think this exam would be Thursday. So I'm thinking that we'll just review for a couple days for the exam, and then like this stuff will be on the exam, rather than trying to squeeze another test in, and then just start.
At 9:20.
Okay. All right. And we'll talk more about that next week, but just heads up on that, and just don't freak out about an exam. You guys will get like a note card to use that you can like kind of like a little cheat sheet. You can have a note card, so kind of putting some of the formulas and stuff on there that you might need. And then the exam is just a little bit longer test. It just encompasses the things from the previous chapters. So hopefully with the note card, you guys will feel okay about it. So I want to remind you guys of ways we know, like these are basically going to be ideas of things we could use in proofs. So ways we know segments are congruent. So thinking about when we get to a proof and I'm trying to show that I have a side that's equal to another side. So one of the ways is using midpoint is one of our reasons we know segments are congruent. So I'm going to draw what it looks like. I probably should have made like a chart of this. I'm going to draw what it looks like. We know that AM would equal MB, and the reason for that is midpoint. So this is something we can use in a proof. And I just want to make sure that's clear on what you can use and what you can't, and kind of try to cover most things that could come up. The next one is one we've been using quite a bit, and that's that reflexive. So when a side equals itself, so if I have I'm just using my little cheat sheet here so I don't forget any of them. And probably the other one with segments being congruent, other than them being given, is a segment bisector. So that's if I have a line and it's like bisected by another line. So I don't need you to say more words than this. So midpoint's fine with me. Reflexive is fine. Segment bisector, I do want you guys to call it a segment bisector, so I don't think it's an angle bisector. Hopefully that's pretty clear when it's segment versus angle. It's either bisecting the segment or it's bisecting the angle. So hopefully that's clear. All right. We have a bunch of ways to know how angles are congruent. What's one of the ways you guys know angles are congruent? Some of the ones that we use a ton. Dr. Levine. Our vertical angles, yeah. So vertical angles. Now the one that showed up in our homework last night that I didn't do a very good job of mentioning. I guess I should probably throw an example in there like that in the future, like with our, we'll actually use one with this today, is if I have like two right angles, I can assume they're equal. You can just say it because they're right angles. And that's one of the ones that seems so obvious, like why would we have to mention that? But I want to point out that they're equal. And then finally is that angle bisector. Now, they do have to give us some information to kind of know some of this. Vertical angles, they shouldn't have to tell us anything. Right angles, something should be labeled. Angle bisector, something should be said that it's an angle bisector. You can't just look at it and say it looks like an angle bisector. The other two that go with angles, if you have room on the side in the margin, I hope, is if you have parallel lines. So if I have parallel lines, remember, we have alternate interior angles. So I have like 7 equals 8. Or I also have corresponding. So if you see parallel lines, you should watch out for those two. Sorry, there's probably not a ton of room for that. So those are ways we know angles are congruent. And then finally, the ways we know triangles are congruent are all our different letter combinations. So we have side, 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 side angle, side, angle, side angle, 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 side, or hypotenuse leg. So those are ways we know triangles are congruent. And we're going to learn one more like set of the acronym when it's all like SSS. So like one more acronym today where once we know triangles are congruent, we can use something that's called CPCTC, which makes it sound like I'm saying random letters to you. It actually has a reason here. We can use that to prove other parts are congruent. So let's talk about that next. We'll do these two parts and then we'll take a little notes break here. Thanks. Yeah, no, that's fine. So what we're going to do today is we're going to still prove the triangles are congruent. Once we know that triangles are congruent, if I know two triangles are congruent, then all the different parts of those triangles have to be congruent as well. So kind of the idea, if you had two identical twins, like so if I say these two people are identical, then all like their arm length, their foot size, their hand size, everything should be identical as well. So so this CPCTC, I'm going to tell you guys what it stands for. So I'll tell you what each letter stands for here. If you're like, oh, I'm never going to remember these letters and what they stand for, again, you'll get a note card for the exam, so don't stress about that. And it's not like you'll have to say this again and again. I'll say it a lot to hopefully help you remember. But what we're going to use this CPCTC for is first we're going to prove triangles are congruent. Once we know that triangles are congruent, then we can also say that all their parts have to be congruent. So all the angles, all the sides must be equal as well. So this is the gist of what we're going to say right now. If we first prove the triangles are congruent, then all their parts have to be congruent as well. So what the CPCTC stands for is kind of confusing because the C's stand for different things. So the first C stands for corresponding. And then P is parts. So we're talking about the corresponding parts. So that's kind of the idea of shoe size, you know, arm length, arm length. We're talking about the corresponding parts. Now then they get kind of mean here. They throw an of in there. Of, they don't have an O in the name. Congruent triangles. Corresponding parts of congruent triangles, and we're going to say are congruent. So I'll show you guys how we use that in a second here. So we will use this typically in a proof. Part of our homework tonight might ask you to do something like this. It says, explain how you can prove that A equals C, angle A equals angle C. So looking at this drawing, A doesn't equal C because of any of our reasons with our triangle or our angles. They're not vertical angles, they're not corresponding angles, they're not, they're not right angles. There's nothing about A and C that would tell us they're equal. But tell me what you guys know about this drawing. What do you know about those two triangles? Yeah. There's a shared side. So there's this shared side in the center. So BD would equal itself. So how do we know the triangles are equal? Side, side, side. So the triangles are equal by side, side. So this isn't really like a proof. I'm just trying to explain ourselves. So the triangles will be equal by side, side, side. And then if the triangles are equal, they're identical. They're identical twins. So if that's the case, if those are identical twins, A has to equal C by this new rule. So then, angle A equals angle C by the CPCTC. So in a proof, that would be our reason. This is just asking us to explain it. So we're able to say the triangles are equal because of side, 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 but then also the angles have to be equal because all the parts would have to be equal as well. So we'll do a few proofs with this today. If you guys look to the back side, we have just a couple proofs and then we're done for today. But like I said, I want to get you guys maybe up and moving a little bit. It's pre-brewery morning, so I thought we could do Would You Rather, but in the room, so you can kind of move to different sides of the room here. I'll just leave a recording. Those of you guys online can fast forward. But I realized I found at home I had to do Would You Rather. Get you guys up and moving. Have to move around desks a little bit, or. Yes, I did. All right. Okay, so here's your first one, very deep question. Would you rather marry an ugly comedian that made you laugh constantly, someone super ugly but they're really, really funny, or a super hot model that only talked about themselves? So, funny comedian, super hot model, only talks about themselves. You guys can all tell Mr. Donahue he's the best of both worlds. So, he's funny and good looking. But I'm over here because I'd rather have funny. All right, so you're grown up and you have to get your first place. Would you rather live alone or have a roommate? So you have your first place. Would you rather live alone or have a roommate? I've actually never lived alone. I've either lived with my parents or roommates or I don't think I would. All right, so you have to pick one to do less of. Would you rather take less showers or brush your teeth less? So you can only do, you have to do one of them less. So either take less showers or brush your teeth less. Yeah, I know. I feel like my teeth have little sweaters on them. Yeah. All right. Hey guys, you go into your kitchen and you want a snack. Would you rather there be an empty refrigerator or an empty pantry? So there's nothing in the fridge over here, or there's nothing in the cupboards with snacks. So nothing in the fridge or nothing for snacks. I like milk too much to have that be empty. All right. So, are you okay with knowing spoilers for a movie? Or are you mad when you hear a spoiler? So you're okay with knowing a spoiler? Or you're ready to punch your friend in the face for telling you the end of the movie?
I'm ready to do it.
All right, here's a deep one for you guys. This one hits at the heartstrings. Would you rather save Mufasa from the Lion King, so you're saving Simba's dad, or Bambi's mom in Bambi?
Well, I like Lion King.
I'm sorry, over here.
I never watched it.
I didn't see Bambi in forever.
Bro.
Same grade.
I'll find one more here. All right, so big, deep argument here. Would you rather only eat Chick-fil-A or KFC? I feel like KFC is kind of going by the wayside. So are you guys Chick-fil-A fans? KFC.
I never had Chick-fil-A.
You've never had Chick-fil-A? I know there's not many up this way.
I don't know what Chick-fil-A tastes like, but I know what it tastes like.
All right, you guys can have a seat.
The last time I had KFC was 2012.
Chick-fil-A, they say, is the hardest franchise to open. They're really, really picky about who they let open a franchise for them. So I guess that's why there's so few. Yeah, there's a, like Milwaukee area, there's more.
I don't want to go back in Milwaukee.
No. Mm-hmm.
Just to have Chick-fil-A.
Just to have Chick-fil-A. There's something about their chicken, it has some sort of like, they use something with pickles that like, pickles on the sandwich. And so, I don't know. That was Mr. Dottie who likes very much, you know, like. Okay.
It is what?
All right, so we're gonna do a few examples here. Okay, so we'll do two proofs. Now notice in what we're trying to prove this time, notice we're not trying to prove the triangles are congruent, or doesn't ask for that. That's your clue that you're gonna end up using CP/CTC. So the fact that they're not asking for triangles to be equal means that somewhere in there you're gonna have to say that they're equal. So anytime you see that, make sure this is clear here. So before we do this, we have to prove the triangles are equal. So before we can do that, we're gonna have to prove the triangles are equal. So that's kind of your clue that you're gonna use CP/CTC in this one. So it tells us S is the midpoint of QT. S is the midpoint of QT. So what do we know? What are we able to say if S is the midpoint of QT? What do you guys know? Yeah, go ahead. There are vertical angles, so that doesn't talk about the midpoint, but sure, we can use the vertical angles. So I'm going to write that down. So Lena mentions there's vertical angles here. So those two angles are going to be equal. So RSQ equals TSU, vertical angles. Okay. So far all we have is angles equal. What else do we know, you guys? No, a few other things. What do you think, Nolan? Yep. So US. QS, thank you. Yeah, the muffled. Yeah, QS equals ST. So again, so Nolan mentions the fact that this should equal that. How do we know that? Because it's a midpoint. So QS should equal ST because there's a midpoint there. Now notice this time it's only the midpoint of the one line as far as they told us so far. So you cannot assume that RS equals SU. They don't tell us anything about S being the midpoint of RU. It probably is, but we can't assume that. They didn't mention that. So right now all we have is an angle and a side. Anytime you guys are stuck and you don't know where to go, like with your proof, go back and look at what they gave us. So that we use the fact, so no one just used the midpoint idea. Have we used the parallel lines yet? No. So parallel lines give us some information. And so if you look at like our warm up today, parallel lines tell us stuff about angles. What do we have in this case then if we have parallel lines? Oh, see it? We have alternate interior angles. There's actually two sets of them. I'm just gonna go, for ease, I'm just gonna go this way. So those are the alternate interior angles, Q and T, because of the parallel lines. Alternate interior angles. Now you can also say that R and U are equal if you wanted to. You don't really have to, because at this point, don't we have enough information to say that triangles are equal? We should, right? Angle, side, angle. So at this point, we can say that the triangles are equal. So before I can prove these segments are equal, I'm going to say the triangles have to be equal. So this time I'm going to be careful about how I name them though. So I'm going to call it QRS is equal to, now I know Q goes with T, so TUS. And I have to look at what I have named up here. And what's our reason that triangles are equal? Angle, side, angle. Now, had you used those other two angles, you could have called it angle, angle, side as well. So there's like options on this one. Now, this is our new steps. This is the one extra step we have to add in. Now that I know those triangles are equal, it's saying these triangles are identical twins. That means all their parts have to be equal as well. So the last step is this QR equals TU. And the reason for that is because if the triangles are equal, so do all their parts have to be equal. And so this is that CPCTC. And I'm telling you guys, the proof probably, 6 is probably about the length of the proofs that we'll have. Now we could have done this proof without the vertical angles, but it's fine. Lena mentioned vertical angles and it worked, like it helped us, so it was good. My notes from the past, like I didn't use vertical angles, we just used alternate interior angles twice. And it's kind of, it's whatever makes sense to you or whatever you notice first is fine. All right, so we're gonna do one more proof together and then you guys will have the rest of the time to work on homework, which the homework does have some proofs in it. So it might be something you want to get going on so you can get help if needed. I'm good with this. Can I flip? All right. So again, looking at this ahead, I'm already thinking about the fact that since it's asking for angles to be equal, I'm probably going to use CPCTC. So kind of like a chess match, trying to be a few steps ahead and thinking about that. All right, tell me what you guys know about this. Probably 3 things that we can kind of come up with at this point. The order doesn't matter, whatever you guys notice that you know. Yeah, go ahead, Izzy. The shared side, yeah. Yeah, so the BD equals itself. So, right, is that, yeah, so shared side. So BD equals BD. And that's, remember, reflexive. Right, she stole the obvious one, maybe. I don't know. Again, anytime you're stuck, look at the given statements. What do those given statements tell us? That it's BD, what's that? Perpendicular to AC. What does that mean? Yeah, so it means that these two are right angles. Now, this is one of the things I didn't do a good job of explaining yesterday. So if they're right angles, what has to be true about those angles? They have to be equal, right? They're both 90-degree angles. So I'm going to say that. So I do want to mention that in our proof, that those two triangles better be equal because they're right angles. So ADB better equal CDB because they're right angles. So we have equal angles there. So I've shown a side, I've shown an angle, and I either need another angle or another side. What else do we know? Yeah, go ahead, Josh.
D bisects AC.
Yeah, so BD bisects AC. So that means that these two are equal little segments, right? Because they're bisected. So AD equals DC. And then we're just going to say segment bisector. Do I have enough to prove the triangles are equal? Yeah, now we do. Now we have enough information to prove the triangles are equal, side angle side, that they're going to be equal. And once I know that, then I can say all their parts have to be equal. So 2 more steps. So triangle ABD is going to equal triangle CBD. Side angle side is our reason. And then once I know that, all the corresponding parts have to be equal as well. CPCTC. So it's that one extra step we're adding into our notes today. So essentially, prove the triangles are equal first, then all their parts have to be equal by that CPCTC. Okay? I know this is not easy stuff, so feel free to check in with me. Come and ask me questions, and let me know if there's something is not making sense. I can usually give you a clue or something like that and get you guys going on it. So homework is listed there. It is 2 separate pages. They should all be in the notes or in the Schoology, I think, already. So all of this is due. I think there are 4 total proofs, I think. Actually, I think I have one I'd like you guys to skip before I skipped 20. Oh, wait, that's not on there. It's 23, that's not on there. So there should be 3 proofs for your homework tonight. Oh, yeah, let me stop. Yeah.